Hello again, I'm Nix, and the topic of today's video is solving the reverse string problem on the LeetCode website. As always, solving this problem in the C++ language and giving you a detailed explanation of the entire process, through the planning of the algorithm, to the coding of it, to the analysis of its time and space complexities. If that sounds interesting to you, then stay tuned. Welcome back, and let's get started. This video should be fairly quick since it doesn't take too many lines of code in order to be able to solve this kind of problem. We want to write a function that reverses a string, or essentially reverses an array. For this problem, the string is given to us as an array of characters, or since it's C++, it's given to us as a vector of characters. Whether you're given a basic array, a vector, an actual string, the main logic to go about solving the problem is essentially the same. We have two examples here to illustrate the point. We're given hello, we want to reverse it to OLLEH, and same thing happens for example 2. For constraints, we are never given an empty array, and our characters that we can run across can be any ASCII character. Finally, a follow-up is we want to essentially do this in big O of 1 space complexity. So, how do we go about solving this problem? Well, in order to do this, especially with big O of 1 space complexity, you're just going to need three things in terms of variables. Two integers that serve as position trackers, and then a third, which is a character variable. And that one is going to serve as a temporary holder so that we can do a swap of the character in the first position with the character in the last position. Now yes, C++ does have the swap function, but I'm not going to use that. I'm going to do it from scratch without that method. But that is essentially the goal. Use those variables, swap the character at the beginning with the character at the end, and then increment up that starting position index and decrement down the ending position index, and then swap again. You're going to do that until essentially those two positions either equal each other or they swap over each other, and now the ending position is less than the beginning position. Once that occurs, you know you've gotten through the entire vector, you swapped everything that needs to be swapped, and you're good to end. So let's code that out. Here are the variables that I was talking about. We have an integer variable I named start position, and it's going to be equal to 0 at the beginning. An integer named end position, and this one is set to the size of the vector that we've been given, -1 to get that ending index. And finally, a character variable that I've just named temp holder, which isn't set to anything at this point. Now we start with a while loop. As long as our start position is less than our end position, this is going to go on. Now for the code inside of the loop. These first three lines here serve to swap the characters. The first thing to do is to assign temp holder a value equal to whatever the character at the starting position is. So S start position. Now that that character is recorded into temp holder, we're free to overwrite that and say that we want that character to be equal to whatever the character is at the end position. So S start position is set to S end position. Finally, now that S position is able to be freed up, we can set that to our temp holder. After we do the swap, we need to adjust our positions. The start position goes up by 1, and the end position goes down by 1. Now with these lines of codes, the problem is solved, and we shouldn't have anything else to do except click some buttons and be judged. So we get exactly what we expect. Great. And let's submit for the full shebang, and we get green text. Excellent. Now for some time and space complexity. For space complexity, you know the answer to this already. Since we only have integer and character variables here, and we didn't create a new array, a new string that have variable sizes, our space complexity is indeed big O of 1. Now for time complexity, this while loop only has assignments and adjustments being made. It's all constant work present here. So the time complexity is going to depend on how long this while loop is going to go for. And this while loop is going to continue until essentially it's gone over and swapped all of the characters in the vector it's given. The longer the vector is, the more times it's going to need to loop in order to do that. So it's going to depend on the input size. Thus, this is going to be a big O of n, where n is equal to the size of the string vector array given to us. With all that said, let's move on to looking at the rankings. Okay, fairly high up on the distribution chart here, which is interesting. I'll come back to this chart after we look at the memory usage, which usually sticks around here. It's a very tight distribution down in this area. And these distributions kind of tell me that there isn't too much variation in the kind of time complexities and space complexities seen in the various submissions. In other words, there's not a big O of n complexity, an n squared, an n log n. You usually get the big O of n time complexity and the big O of 1 space complexity. Now, I want to show you before we end what these answers look like, the most optimized runtime ones. Now, if you didn't already know, if you click on these bars here, it'll show you a representative code submission that has that runtime. Now, what do we get when we click, say, this highest one? The method to reverse essentially just calls reverse, which kind of gives you a good feel for just how optimized these built-in methods do. Although I wouldn't recommend trying to do this if you were given this problem on a technical interview. But fun to look at where it's seen on the distribution. I think this one is the one, that uses a swap instead of doing it from scratch. And with that, that was how to solve the reverse string problem. I hope this video helped you out in some way. If it did, consider subscribing. I do these types of videos twice a week. And as always, I will wish you happy coding and to have a nice day.